Hi friends, welcome back. So let's continue our supervised learning playlist, right? So today we are here with the PIMA diabetes data set. Last time we have seen the same scenarios with logistic regression, but this time we will check with Niave Bayes. So to filter it out that how many people likely to develop diabetes, right? So again we will use Niave Bayes to model the PIMA diabetes data set, which I'll provide the link in the description. So the model will predict which people are likely to develop diabetes again, right? So let's start with our importing and doing our analysis. So first we import the libraries, again NumPy for linear algebra, all the numerical uh, calculations, and pandas for data processing, like importing CSV file, exporting them, right? Import matplotlib.pyplot as plt, so this will be again to plotting our all the data, and similarly seaborn again for the visualization. Now let's load and review the data. So again we are getting the PIMA diabetes data in P data. Okay, now if we check the shape or the number of rows and column in our data set, so you can see that these are the number of rows and these are the number of columns, right? Now we are checking the head or the top 5 rows of the data set. So you can see that this is the top 5 rows, that fragment, plus, pre, skin test, mass, right? All the medical reports or the of the Indian data set, right? Now checking the null value. So again getting the p data dot is null, where it is checking whether the values are null or not, and we are getting is null dot values dot any. So if there is any null value, it will return true, else it will return false. Now getting the column. So here you can see that we are excluding outcome column, which has only what. So you can see that list we are getting p data 0 to -1, right? So only excluding outcome column. So here by that we are only excluding the class column. Okay, so the class column will be excluded. Now we are getting the histogram. So here you can see that p dot data columns histogram, right? Stack is false, bins we are getting 10, right? Figure size we have to find 12 by 30, and layout we are getting the whole layout in 14 by 2. Now you can see that this is the histogram of first 8 column, right? So the plus brag. Okay, so you can see that. Now next thing is the identify correlation in data. So again, to getting the correlation, we simply use the core function, right? So from p data, that our data set, and we will get the core function. So basically it will return the correlation matrix we have, right? Prag with prag, prag with plus, prag with press, prag with the skin, so on so forth. And diagonal, you can see the value is 1, because prag is 1, plus with 1. So here you can also correlate with that. Now next thing is, however, we want to see correlation in graphical representation. To below is a function for that. So yeah, again plotting or getting the whole correlation in the graphical representation, you can see that we are plotting this in this way. So here again the diagonal value, you can see the other values, you can see that, right? So basically here we have to pass the data frame and the size, then the correlation function, figure for the subplots, and the axes for showing correlations, right? And we are giving x stick, y stick for the correlation columns. Okay, so this way you can get that. And in this plot, yellow color represent maximum correlation, right? And blue color represent minimum correlation. So the maximum correlation, you can see that, and the blue, that is this one, is the minimum correlation. We can see none of variable have correlation with any other variables, right? Because now we are getting the pair plot. So again the kind we are giving KDE. So you can see that for each and every class we are getting the pair plot, right? So this is how the scattered is there. Now let's calculate diabetes ratio of true false from outcome variable. So what we'll do is, first we'll define true variable, then false variable. Or in true variable, it will contain the class which have true values. True value in the sense that you can see that we have 1 and 0, right? So 1 is for true and 0 is for false. Okay, then similarly for false again, yeah, and false, and printing the number of true cases, so it will print all the number of true cases, that means all the number that has a true value, and for false all the values for false cases, and simultaneously we are getting the percentile value for them, like how percentage is for true value and what percentage is for false value. So here you can see the 34.9% people in current data set who have diabetes, and the rest 65 doesn't have diabetes, right? So it is good distribution, that of true false cases of diabetes in data. Okay, now we are splitting the data, so I will use 70% of data for training and 30% for testing. So to get that train test split, we are importing it from model selection in sklearn, defining x for to get the column and y for the predicted class. So x is nothing but the predictor feature column, right? It will exclude the class or the last values. Okay, so we are dropping the class and having the rest column here. Now as it is the predicted class, so here we will get the p dot class column only, so where 1 is true and 0 is false. Okay, now x train accessed, y train y test. So in the train test split we are passing x, y, and the test size we are giving 30%. Again, 30% is nothing but our testing. Okay, we are giving the test size here, and the random state is again high or 1, or it could be anything, like each and every time you will get the same train test split, right? So this is nothing but the seed number. Now we are getting the x train hat here, so you can see that the x train value that we get for pre, plus, press, skin test, mass, right, paddy and age. So now let's split, now let's check the split of data. So what we'll do is we are printing two statement. In first we are getting the percentage that data is in training set, right? And second one we are getting the percentage that the data is in testing set. So for this one format, we are getting length of x train divided by length of p data dot index, right? And then multiplying with 100 to get that percentage. So here you can see that 69.92% data is in training data and 30% data is in test set, right? So now let's check diabetes true false ratio in split data. Okay, so here you can see that we are getting in the formatting shape. Okay, so what we did is, let's say first one is for original data, original diabetes true value, right? So how many original diabetes are true, I mean true values are there? So we are getting it from p data, right? We are accessing that class with the log function in the p data itself, and telling that if it is equals to 1, right, then only give me that p data. Secondly, we are telling that what is the percentage for it. So again, if the p data class equals to true, right, then return that p data and divided that p data with the length of p data dot index, that means to get the percentage. So here it will return me the 34.9%. Similarly, you will get the value for original diabetes false values, then same as training diabetes true values, training diabetes false value, and same as test diabetes true values and test diabetes false value. So this way you will get the true false ratio in the splitted data. Now we have next step is to data preparation. So what we will do is, here we are checking hidden missing values, right, first. So as we checked missing values earlier but haven't got any, but there can be lots of entries with zero values, so we must need to take care of these values. So again, first getting the head values here, and we can see lots of zero entries above. Even in the head itself you can see that zero entry, zero entry, zero entry, right? So we have to impute that. So what we can do is we can replace zero with serial mean, one of the best way. So for that we will get the simple imputer from the sklearn.impute. We are defining a variable that is rep0. It will get that simple imputer for missing value 0, it will the strategy that we will have is mean. Okay, column, that which column we will get from xtrain dot column, and xtrain will now will be pd dot data frame and rep 0. That means we have imputed that null values or zeros values, and we are fitting the transform again with the xtrain. Similarly, we are doing for the test data set, and we are telling that pd dot data frame rep 0. That means imputing the 0 values and fitting the transform with the x test here. So in the next xtrain columns and xtest column, you will get the calls, because calls we have already get the old xtrain dot columns, right? So this time you can see that the 0 that we had here is replaced by mean. One is for 467, right? So here you can see that all the values have been replaced by its mean values. Okay, so this way you can get the mean values as well. And now comes to the train the Niave Bayes algorithm, which was the main aim of this tutorial. So here you can see that again, to get that Niave Bayes, we are getting it from sklearn.niave Bayes, importing Gaussian Niave Bayes. So using Gaussian algorithm from Niave Bayes. Okay, now creating the model. So you are defining a variable and getting that Gaussian Niave Bayes in that variable. Now the model dot fit will be xtrain ytrain dot rebel. Okay, so Gaussian NB will be priors none, and variable smoothing will be LE, that is 09. Performance of our model with training data. So what will be the performance of our model? So to get that performance, here we have already fitted the the Gaussian Niave Bayes passing xtrain and xtrain dot rebel. So here to getting the performance model of our training data, we are calling the model and telling that okay, just predict our xtrain. So it will contain all the prediction in this predict variable. So now we are getting the matrix from sklearn, and we are printing the model accuracy. So format, right? Formatting we are giving for model accuracy, that is matrix dot accuracy. That means this matrix, and accuracy score containing in the matrix, and we are passing the ytrain and the variable that we got the model, or the after fitting the model. So here you can see the model accuracy we have is 0.7616, right? Now the performance of our model with testing data, it was with training data, same goes with testing data. So if you pass the y test here, right, y test and the fit model, so here you will get the 0.78 is for our testing data. Okay, so let's check with the confusion matrix and classification report. So here you can see that the confusion matrix, basically confusion matrix and the classification reports are the evaluation of the model. Confusion matrix is only based on all these four values: true, false, true, negative, false, positive, and false, negative. Whereas the classification matrix is the that is based on the confusion matrix. First we'll get the confusion matrix here. So you can see that we are passing the confusion matrix y test, right, test prediction label 10, and pd dot data frame cm. We are giving index I for I in 10, columns I for I in predict 1, predict 0. Now plt dot figure, that will be fixed size, we have 7 to 5, and sns heat map we have df cm, that is anode true. So here you will see that we are getting the predict 0 and predict 1 for the confusion matrix, right? And what is the true positive, true negative, false positive, and false negative values that we have here. And same goes with the classification report, which is purely based on the confusion matrix. So to get the classification report, we are printing it from matrix.classification report, passing y test, right, the variable that we had, and the labels, that 1 and 0. So classification report will look like this. So here you can see we will get the precision, recall, f1 score, and support, right? So all these are based on the measurement, like precision is the measure of the correctness that is achieved in the prediction, right? Whereas recall is nothing but the measure of completeness or actual observations. were predicted correctly, right? And we have F1 score as well. F1 score is for combined precision and recall in a single term, that is also known as the harmonic mean. Okay, and finally we have the support. So support is nothing but, and finally we have the support, and similarly goes with the 10 micro, right, macro and weighted average values. So yeah, we can see our true positive number with value 1 is of precision and recall, and that is below 70%. So you can see that our precision and recall, right? So for precision it is 75%, and recall is 62%. So yeah, friends, this was all about the Niave Bayes using, the diabetes data set that we have done earlier, and this time we have done with the Niave Bayes as well. Hope you got a slight idea that how we use this same problem with two different algorithm of the supervised learning. We will also try to make an example and to solve all the supervised learning, and we can see the difference there, right? You can also do that with your own. So yeah, for today, thanks. We'll get in touch in the next video.